Hello, everyone. I hope this video finds you well. Today, we're going to talk about organometallics or Grignard reagents. Um, Grignard reagents. Remember the first time I tried to pronounce these are kind of rough. But anyways, so Grignard reagents are probably one of my favorite parts of this class, mainly because they're really, really useful for just doing things and reacting and whatnot. And so let's go ahead and let's make some Grignard reagents, right? First, before we go about and do things. Hold up, let me just. Oh my God, I lost my notes. Lord, I have like a bajillion tabs open right now. That's okay. Alrighty, cool. So if to make a Grignard reagent, right, you'll take you can either do it with Li or Mg, magnesium or lithium. So there's probably more out there, is my guess, but this is the stuff that you're going to be taught in class right now. So if you have a alkyl group, R just stands for just any like structure that you can have, right? If you have an R group, for the most part, and you throw it in, right, with Li two equivalents, you're going to get something along the lines of this Li, then you have a byproduct of LiBr, right? And if you want to make a Grignard reagent with magnesium, you're going to take, right, a R group, right, attach it to a Br, right, and this Br it doesn't have to be Br, by the way. It can be chlorine or iodine as well, and then you end up with something along the lines of you end up with this RMgBr, right? And Grignard reagents can come in all sorts of different shapes and sizes, right? I'm just going to choose random ones here. You can have something along the lines of this, right? As an example of this, or you can have something along the lines of this. You can even have a whole ass ring attached to these, right? And so the purpose of these, right, is that they're going to enable whatever structure you have attached to the metals, right, MgBr, Li, to be super, super, super nucleophilic. And you basically, right, in this case, can essentially add on an aryl group, or you can add on an alkyl group. And so what you'll frequently find in this class is that, let's say, for example, I had these structures right here, right? Grignard reagents are really, really good at reducing things. And so if you remember, reducing means a reducing reaction is any type of reaction that takes away bonds from an oxygen. And so, for example, if I had something along the lines of this, right? If I had Li, had that thing over here, right? Let's see, 1, 2, 3, 1, 2, 3, right? And so the mechanism will be something along the lines of this. It will go in, it'll tap onto here, and then this will pop up on here. And then you end up with something along the lines of this. 1, 2, 3. Yep. And you'll have that Li kind of floating off on its own somewhere. And so, yeah, as you can see here, right, this organometallic over here, right, this lithium really just came in here, bam, attacked, pushed onto here, right. These, as to keep in mind, right, Grignard reagents are super reactive, super aggressive, I would say. And so another example of this, right, is if I took that MgBr over there, right, MgBr, very, very similar as well, right? Just follow the blue arrows. It's going to go in, attack from here. This is going to pop off onto here. Then you're going to end up with something along the lines of this. Yep. Oops. And so that's an example, right, of what Grignard reagents can do, right? You can do reducing. But also, honestly, you can also use Grignard reagents, right? As I as drew here, but then I actually forgot, right? You can also use them as a type of reactant for an SN2 reaction. So I'm just going to use one example here, right? If I took that MgBr, you move in, attack from here, right? This pops off onto here. Then you end up with something along the lines of this. One, two, three, 1, 2, 3, and then everything else is accounted for. 1, 2, 3. Gotcha. Yep. And so this is a very, very basic. These two are going to be the main functions you'd use for Grignard reagents, but also on top of that too, they can also react with water. So I'm just going to use Li for this. Right. Yeah, for the water. Right. 1, 2, 3, Li. Right. If you had water, some of the lines of this. You end up forming something along the lines of 1, 2, 3, 1, 2, 3, right? And then, oh, hold up. Sorry. I did this wrong. I did this wrong. Oof. You'll end up with a, let me triple check these notes here. Remember this is briefly mentioned, right? But I don't remember this being super, super. Ah, yes. Okay. Okay, I did this right. Never mind. Yeah, I'm just not used to doing this type of reaction, so I was a little confused there. 1, 2, 3, 3. I'm gonna have the rest of the H's here. And then you'll end up having a LiOH because lithium kind of goes passes itself onto here. Yeah. Alrighty, cool. So those are Grignard reagents. Those are really useful. They're mainly going to be used probably for reducing, so that's where you're going to see them here. And so I recommend that you guys kind of get used to using Grignard reagents, especially when you're doing synthesis. And I hope you guys have a good day and keep studying.